Welcome back. Today we're going to talk about section 5.5, addition and subtraction of polynomials. Question 1 says, given the polynomial, and it gives you the polynomial, write the polynomial in descending order. So we need to go identify the exponent that's the biggest, which is to the fifth power. So I'm going to write negative 3x to the fifth. That one's gone. There's not an x to the fourth, but there is an x to the third, so minus 2x to the third. There is an x to the second power, so plus 2x squared, then plus 6x minus 10. That's part A. Part B says to identify the leading coefficient. The leading coefficient is the number in front of the highest power of x. So in this problem, the leading coefficient would be negative 3. Now it says to identify the degree of the polynomial. The degree is the highest exponent of x. So this polynomial is of degree 5. Number 2, categorize the expression as a monomial, a binomial, or a trinomial. Then evaluate the polynomial given x equals negative 3. Okay, monomial means one term. Binomial means two terms. Trinomial means three terms. Now, a term is the number and an x to a power. So this is a term and this is a term. I've got 7x plus 3x to the fourth. So that means there's two terms. So this is a binomial. Okay, the second step is to plug in negative 3 everywhere you see an x. So 7 times negative 3 plus 3 times negative 3 to the fourth. I'm going to go open my calculator because I don't enjoy doing arithmetic by hand. Okay, I am going to show you on the calculator two different ways to do this. The first way, I'm going to type in exactly what I see in blue. So here we go. 7 parenthesis negative 3 plus 3 parenthesis negative 3 to the fourth. My answer is 222. All right, another way I'm going to do this. Do you see this little store button above the on? I'm going to put negative 3 and store that for x. So I'm going to hit enter. Every time I type an x, the calculator thinks I typed negative 3. So then I just have to type in my polynomial, 7x plus 3x to the fourth. I get 222. This is helpful when you have to evaluate a polynomial at several different values for x. You don't have to type out the whole thing over and over. All right. Moving on to question 3. Categorize the expression as a monomial, binomial, or trinomial. And then evaluate the polynomial when b is negative 2. Okay, 5b, that's one term, minus 11b squared, that's a second term, minus 7, there's a third term. This is a trinomial. If I wanted to write this trinomial in decreasing order, I would write it as negative 11b squared plus 5b minus 7. And just a quick review, leading coefficient is negative 11, and the degree of this polynomial, this is degree 2. That's just a review. Okay, but that isn't what this question's asking. It wants you to evaluate the polynomial when b is negative 2. So here we go. 5 times negative 2 minus 11 times negative 2 squared minus 7. Everywhere I see b, Everywhere I see b, I'm going to plug in -2. Okay, on my calculator, just to show you the process again, I'm going to type -2 and store that for my variable x. Then I'm going to type in 5b, so 5x, minus 11x squared minus 7. I get -61. If I type this in just like it looks, I should get -61. So this is another way to do it. 5 times -2 minus 11 times -2 squared minus 7, -61. Question 4. Categorize the expression as a monomial, binomial, or trinomial. Then evaluate the polynomial given x equals -2, y equals -4, and z equals 1. The polynomial is 8. There's just one term. There are no variables there, but there's one term, so it's a monomial. Now evaluate it given these values of variables. Well, like I said, there's no variable in there. No matter what x, y, and z are, the polynomial is always 8. So the value of the polynomial is 8. Question 5, add the polynomials. Okay, let's go talk about what it means to be like terms, because you can only add terms that are like. With a polynomial, the variables and the exponents have to look exactly the same. So -15xy squared plus 3xy squared, those are indeed like terms. So my answer is going to be some number xy squared. Okay, so what's the number? I have -15 plus 3. So -15 plus 3 is -12 xy squared. So one more time. I go look and make sure that the variables to the exponent are the same, and they are. -15 xy squared plus 3 xy squared. And the number is going to be, what is that? -15 plus 3 is -12 xy squared. Number 6, add the polynomials. Okay, my first polynomial is a monomial, and then I'm adding a binomial to it. So here we go. I'm going to write it all out. 3x to the 4th y cubed plus 8x to the 4th y cubed minus 7y. I don't need the parentheses because there's a +1 out front, so I can just get rid of them. Okay, like terms. 3x to the 4th y cubed plus 8x to the 4th y cubed. Those are like terms. 3 plus 8 is 11x to the 4th y cubed. And then I still have this -7y. The x to the 4th y cubed and the y, those are not like terms. So this is it. That's your answer. Number 7, add the polynomials. I'm going to go write them all out first. T squared plus 5t minus 3t to the 4th. Okay, plus, so I don't need to distribute anything, so I'm just going to write plus 2t to the 4th plus 4t minus 5. Okay, this is where I do encourage you to get colored pencils. It will help. Okay, let's go circle all of the t to the 4ths. I have -3t to the 4th plus 2t to the 4th. -3 plus 2 is -1 t to the 4th. Are there any t cubes? No. Are there any t squareds? Yes, just this one. So I'm going to write plus t squared. Okay, next is t to the 1, so just t. I have 5t plus 4t, so I get plus 9t. And then I still have the constant term minus 5 out here. That's your answer. You do not need to put the negative 1. That 1 is understood, so you could just write that as negative t to the 4th plus t squared plus 9t minus 5. Number 8, add the polynomials. Okay, they give this problem to you in vertical format. So they've already got all the x's lined up, all the y's lined up, and all the z's lined up. So the x's, 12x plus negative 4x would give you 8x. Now the y's, 4y minus 6y gives you negative 2y. And last, the z's, negative 7z plus 6z is negative 1z, so I'm just going to write it as negative z. Number 9, I'm going to write all the terms out. Ooh, we have fractions, but the calculator can do fractions, so I'm not going to worry about it. I have 1/4 w plus 3/8, okay, plus negative 3/4 w squared, so that's just minus 3/4 w squared, minus 1/4 w, and plus 3. And my highest exponent is w squared. So there's only one of those terms with the w squared, so negative 3/4 w squared. Now let's go talk about the w's. I have 1/4 w minus 1/4 w. 1/4 minus 1/4 is 0. So those are gone. And then for my constant term, 3/8 plus 3. All right, here we go. I have a fraction, 3/8 plus 3 is 27/8. So there's my answer. Negative 3/4 w squared plus 27/8. Number 10, find the opposite of the polynomial. I'm thinking they're wanting the additive inverse. So the opposite is just multiplying the entire polynomial by negative 1. I've got to distribute. So the additive inverse of this polynomial would be negative 9n plus 12. Number 11, find the opposite of the polynomial. Again, that means to multiply the whole thing by negative 1. And I need to distribute the negative 1 to every term. So the opposite of that polynomial would be 10.6 x squared plus 5.8 x plus 7.5. Question 12, subtract the polynomials. So I have 3ab to the 5th minus 7ab to the 5th. Again, these are like terms because my variables raised to the exponents are exactly the same. So I can say 3 apples minus 7 apples would give me negative 4 apples. So the variables to the power don't change. 3 of those things minus 7 of those things gives me negative 4 ab to the 5th. Again, you keep the variables to the powers. You don't do anything to the letters and powers here. You're just adding or subtracting the numbers that are out front. Question 13, subtract negative 31c minus 10c. Those are indeed like terms. They both have just times c on them, so the answer is going to have a c. Negative 31 minus 10. Negative 31 minus 10 is negative 41. So negative 31c minus 10c is negative 41c. Number 14, subtract the two polynomials. 3k plus 15v minus quantity 7k minus 3v. Okay, I'm going to tell you, subtracting is just like adding. I just need to distribute the subtraction, the negative up front. So I have 3k plus 15v minus 7k, and the negative and negative is b plus 3v. Now let's go find like terms. I have 3k minus 7k. 3k minus 7k is minus 4k. Now let's go find the v's. 15v plus 3v is 18v. So my final answer is negative 4k plus 18v. Number 15, subtract the polynomials and simplify if possible. Okay, I've got a subtraction sign here, so I need to go distribute so I can get rid of all the parentheses. I have 25m to the fifth minus 23m to the fifth minus 13m. I've distributed the negative, negative 23m minus 13m. Okay, do I have any like terms? Highest power of m is m to the fifth. I have 25m to the fifth minus 23m to the fifth. 25 minus 23 is 2m to the fifth minus 13m. And that's it. I cannot combine m to the fifth with m when I'm subtracting. My final answer is 2m to the fifth minus 13m. Number 16, subtract. Do not panic just because you see fractions. Your calculator can handle the fractions. But I do need to get rid of the parentheses. I've got to distribute that negative to both of those terms. 5/7 y plus 4/5 z minus 4/13 minus 4/7 y minus 2/5 z. Like terms, let's go get the y's first. 5/7 y minus 4/7 y. On my calculator, 5/7 minus, what was it? 5/7 minus 4/7. 5/7 minus 4/7 is 1/7. If you're the type that likes to do fractions this way, 5/7 minus 4/7, make sure they're in parentheses, you're going to have to hit math, and number 1 says turn it into a fraction. If you don't like using the fraction by doing the alpha y equals here in the beginning, you can also just type it in, but you're going to have to say turn my answer into a fraction. All right. Oops. 5/7 y minus 4/7 y is 1/7 y. Now let's go after the z's. 4/5 z minus 2/5 z. Here we go. What was it? 4/5 z minus 2/5 z is 2/5 z. And then don't forget, we still have the constant term minus 4/13. So my final answer is 1/7 y plus 2/5 z minus 4/13. Number 17, find the difference of this polynomial and that polynomial. So I want to put a minus sign between them. Find the difference. I'm going to need to distribute that minus sign to all three of those terms. So let's rewrite negative 5h squared plus 3h minus 20 minus a negative 9h squared becomes plus 9h squared minus 9h minus 6. Let's go combine like terms. Negative 5h squared plus 9h squared is 4h squared. Now for the h's, plus 3h minus 9h, 3 minus 9 is negative 6. 3h minus 9h is negative 6h. Now for the constant, negative 20 minus 6 is negative 26. Your answer is 4h squared minus 6h minus 26. Number 18, subtract this polynomial from that polynomial. So we're going to start with 8a squared plus 4a minus 17, and we're going to subtract 3a cubed minus 3/5 a minus 9. We're going to subtract this one from that one. So let's go distribute this negative sign to all three of those terms. 8a squared plus 4a minus 17 minus 3a cubed plus 3/5 a, minus a negative was plus, and then minus a negative 9 is plus 9. Okay, what's the highest exponent on the a? I see a cubed, but that's the only one I see. So I'm going to write negative 3a cubed. The next highest power is squared. That's the only squared term I see, so this is just plus 8a squared. Now the a's, 4a plus 3/5 a. 4 plus 3/5. 4 plus 3/5 is 23/5. So 4a plus 3/5 a is 23/5 a. Now for the constant, negative 17 plus 9 is negative 8. Your answer is negative 3a cubed plus 8a squared plus 23/5 a minus 8. Number 19, find the polynomial that represents the perimeter of the figure. Simplify your answer. The perimeter is the sum of the lengths of all the sides. I'm going to add up all 5 sides. If I add up all 5 sides, the highest exponent I see is t cubed. So let's go circle all the t cubes. 4t cubed, 4t cubed, 1t cubed. 4 plus 4 plus 1 is 9t cubed. Now let's go add up all the t squareds. Let's see here. I'm going to do blue. No t squareds there. Oh, 2t squared minus t squared plus 2t squared. 2 plus 2 minus 1 is plus 3t squared. Do we have any t's? No. But we do have constants. Negative 10 minus 10 plus 9 plus 2 plus 9. Okay, here we go. Negative 10 minus 10. Oop. Negative 10 minus 10 plus 9 plus 2 plus 9. My constant, is 0. So you could write plus 0, but you don't need to. The answer is 9t cubed plus 3t squared. Number 20. If the perimeter of the figure can be represented by the polynomial, here's the perimeter. Find a polynomial that represents the missing side. So this side. I know that 7w cubed plus 4w plus 10 has to equal that's missing side plus something. So what is all of the rest of these other three sides? What do they add up to? Well, I have 6w squared, 2w, oh, I need cubed first, sorry. I have 2w cubed, okay, w squareds. 6w squared plus 6w squared is 12w squared. Okay, I don't have any w's, but I do have a constant term. 7 plus 7 minus 4, 14 minus 4 is plus 10. Okay, I need to get the star by itself. So I want to subtract 2w cubed from both sides. I would get, what is that? 7w cubed minus 2w cubed is 5w cubed plus 4w plus 10 equals the star, and then what's left, plus 12w squared plus 10. I want to subtract the 12w squared from both sides. Now there's not one here, that's why I left a space. So minus 12w squared, and I also need to subtract 10 from both sides. When I do that, those are gone. On the right, I'm just left with the star. So that star is equal to 5w cubed minus 12w squared plus 4w, and that's it. Perform the indicated operations. I need to subtract, so I need to distribute this one. And subtraction means to distribute this one as well. I have 10 s squared t minus 5 st plus 8 st squared plus s squared t minus 4 st minus 7 st plus 5 st squared. Okay, first term that's the exact same. I see s squared t. Are there any other s squared t? Yes. That's it. So 10s squared t plus s squared t is 11s squared t. Next, like term, do I have any other st's? Yep. Any other? Oh, yep. Okay, negative 5 st minus 4 st minus 7 st. Negative 5 minus 4 minus 7 is negative 16 st. Any other like terms? 8 st squared. So do I have any other st squareds? Yep. 8 plus 5 is 13 st squared. That's it.